In this video series, I'll be walking you through how I created this interactive dashboard. All of this was done using Quarto, GitHub Actions, and GitHub Pages. It was completely free to create and to host, and all the interactivity that you see here is powered by Observable JavaScript, without the need for a shiny server. This dashboard displays the Today's Top Hits playlist from Spotify, and is automatically updated every day at 9 a.m. without me needing to do anything at all. I never have to render any of this code locally, since GitHub Actions takes care of everything for me. And the code is 100% reproducible, because this project uses renv to manage all the R packages and package versions. I created this dashboard as my submission for Posit's 2024 Table Contest, and my idea with my submission was to combine as many different tricky components as possible into one Quarto project. Throughout this series, we'll talk about how to create and style Quarto dashboards, how to publish them for free using GitHub Pages, and how to automatically update them on a schedule of your choosing using GitHub Actions, how to include passwords and other confidential information as part of your GitHub Actions workflows, how to use Observable JS to add interactivity to your dashboards, how to use the Hitter2 package to access APIs, and of course, how to use the GT package to create beautiful, interactive tables. This playlist contains 7 videos, and in this series, we'll build up this dashboard step by step from scratch. I've designed this playlist, though, in such a way that each topic has its own video that's fully self-contained. That means that you don't need to watch all 7 of the videos in this playlist in order to get value out of the video that you're currently watching. If you do watch all 7, though, you'll be able to completely reproduce this dashboard, and you'll also have all the tools you need to create a similar project of your own. My name is Melissa Van Bussel, and I make videos about R programming and data science. If you find these tutorials helpful, please consider subscribing to my channel, since it really helps me make more videos. Without further ado, let's jump into this video's topic. This video is going to be all about how I went from point A to point B. I'll talk about how I made this table on the left, and then how I did all of the styling in order to go from something very plain like this to the finished product. In the previous videos, we had talked about this top hits data frame, which contains the variables song name, song ID, artist name, a link to the album art, how long the song is in milliseconds, popularity, and tempo for each section of the song. I want the table to go in the first column, so I'm going to create a new code chunk underneath the one where I defined that top hits data frame. I'm giving a name to this chunk, and this time I do want the outputs to show up in the dashboard, so I'm not going to include any chunk options. I'm going to be using the GT package, which means I need to load it up here, and because I've never used the GT package in this project so far, I'm also going to need to install it, and that's going to be installed into the repository for this project using renv, and I'm also going to update the renv.lock file by running the snapshot function from the renv package. Now I can take that top hits data frame and we can pipe it to the select function to specify which variables should be included in the table and in which order. I want the album art on the left, then the name of the song, the name of the artist, the duration of the song, popularity of the song, and the tempo. Then we pass that to the GT function, and we can take a look at what that looks like so far. So we have a basic table now with the column names that were specified. Next, let's give each column a proper label. You can use the calls label function. Now for the album art, I don't actually want there to be a title for that column. I want it almost to look like the album art is attached to the song name. So the column name that I want to have is just going to say song, but I want that to look as though it appears over both columns. So for album art, I'm going to put the column name as song, but I'm going to make the column bold So I can use the MD function for markdown, and then I can make the title bold by wrapping it in the stars. For song name, I'm going to leave the title completely blank because I want it to look like it's attached to album art. For artist name, using the MD function again, but I'm just going to call it artist. For track duration, for now, I'll just have it say duration. I'll update this a little bit later to make it look slightly better. And that's the last one. And this is what it looks like after I apply that. So now I've got bold column titles. From here, we're going to transform some of the values. Right now, this is just showing a URL, which isn't the most useful. So we're going to convert that so that it shows up as an actual image. And we can do that by using the text transform function. And the function that we want to apply is the web image function. And I'll set the height to 50 for now. And then the columns that we want to apply this to is just the one column, and that's the album art column. Let's apply that. And now I've got an image, and it also appears like the album art is attached to the name of the song. Next, I want to transform this duration column so that instead of being expressed in milliseconds, it's expressed in minutes and seconds. I'm going to use the format function, and the columns that we want to apply this to is just the track duration column. And the function that we want to apply is we're going to take the track duration and calculate the number of minutes. So we can take the floor of the track duration divided by 60,000. Then we can extract the seconds as well. And finally, we can define how we want to display it in the table itself. And if we look at the documentation for the sprintf function, we can see that D means integer value. Then we have a colon. And this part right here is saying that we want it to take up exactly a width of 2. So if the amount of seconds is less than 2 digits, put a 0 in front of it. Otherwise, keep it as a width of 2. Let's see what that looks like. And now we have much more easily readable durations rather than the milliseconds that we had before. To finish off this duration column, I also want to change the word duration to a little clock emoji, since that's what it looks like on the Spotify web player. And to do that, I'm going to replace this column label with a clock emoji. But I want the clock emoji to be all one color, and specifically I want it to be all white. So I went to this website, icons8.com. I searched for a clock, and then you can change the color to anything you like. So here I'm changing the color of the clock to white. It's a little bit hard to see since it's on a transparent background. But then once you've changed the color, you can click this copy button, and then I'm going to copy the SVG code. And then I'm going to replace this label, and I'm going to put in that code that I copied from the Icons8 website and wrap it inside of the HTML function. And then I'll just paste that right in between single quotes. And let's see what that looks like. So right now it's showing up as white. So in order to be able to see this a little bit better, let's go ahead and add the tab options function and set the color for the background of the table. So I'm going to make the font color white, but I'll make the background color a color that's pretty close to black. Let's try rerunning that again. And now the clock image is showing up, but it's really, really large. So let's make that a little bit smaller by changing the width down to, let's say 15, and adjusting the height as well. Rerunning that, the size looks a lot better. Next, I'm going to convert these values in the tempo column and turn it into a nanoplot, which is a relatively new feature in GT that allows you to embed interactive plots inside of your GT tables. So we can use the calls nanoplot function. And first I'm going to specify the columns where the data should be pulled from. And in this case, it's just from that tempo column. I want the plot to be a line plot. So plot type equals line. Then we're going to give it a new column name. So right now it's just called tempo, but we can call it tempos. But we want the column to be displayed in a way so that it still says tempo. Using the markdown function again and making the column name bold. And then we need to pass some nanoplot options to control the styling of the plot. We want the fill color to be a Spotify green sort of color. And I want the stroke color to be the same. Let's make the fill color for the data point bounded area also that Spotify green. And then just so that everything isn't all the exact same color, let's make the lines a purple color. And I think this color goes fairly nicely with that Spotify green. And let's take a look at what the table looks like now. It takes a little bit longer to render, but now we have this interactive plot inside of the table itself. In terms of the column content, we've really only got one part left, which is transforming this popularity column. And what I want to have happen is I want each of these popularity values to be inside of a circle, but I want the size of the circle and the color of the circle to be proportional to how popular the song is. So if the song is really popular, I want the circle to be bigger and have a color that is green, let's say. And if the song is less popular, I want the circle to be smaller and maybe have a color that's red. So I want to create a gradient of colors from green to yellow to orange to red. And then I also want the size to be a function of the popularity value. For this, I used ChatGPT. And what I did was I went to the GitHub repository for the GT package. I cloned the entire thing locally. And then I asked ChatGPT to write a function in R for me to extract all of the .rd files from the cloned GT package and combine all of it into a single text file. In other words, I asked it to take all of the documentation files from the GT package and combine them into one text file. And the reason why I did this is because ChatGPT doesn't have the most updated knowledge, and GT is still a fairly new package, especially with a lot of the newer features like nanoplots. And so while I was working on this table, I wanted to be able to ask ChatGPT questions and have answers that are current. And I also have GPT Plus, so I can upload documents into the conversation and ask ChatGPT to read those documents before giving me an answer. So here I'm going to ask it to write me a function that generates an SVG circle as a function of column called popularity, which ranges from 0 to 100. The size of the circle should depend on the value of popularity, where larger values represent larger circles. The color of the circle should also depend on the value of popularity. High values should have a green color and low values should have red color, and the colors should be on a gradient scale. Then modify the GT table below to replace the current value of the popularity column with the SVG code that was generated. Please read the attached documentation before you provide any answer. And then I'm going to paste in the code that I already have so far. And I'm also going to upload the GT documentation. Something that I've found with GPT Plus is that even if you ask it to read the attached document before providing an answer, sometimes it will and sometimes it won't. And if it doesn't, you'll have to prompt it again to actually read the document. It might tell you that it's read the document and that it doesn't know how to answer your question, but unless you see a little like loading symbol saying reading documents, it might not have actually read the document that you attached. So now we have an answer from ChatGPT, but these things usually don't work perfectly right out of the box. But let's see how close we can get on a first attempt. So first I'm going to copy this generate SVG circle function and put it above. And then here it's using the mutate function to apply the generate SVG circle function to the popularity column. So let's copy this part. I've already loaded those packages, so I'm not going to copy that portion. So let's run this generate SVG circle, and then rather than this saying modified df, I still want this to say top hits df. So we're getting an error here. Let's just make sure that popularity is being interpreted as a numeric value. Rerun. That actually involves me regenerating the entire data frame. And just so that we don't have to do that again, I'm going to, instead of overwriting the popularity column, I'm going to create a new column called popularity SVG. And for good measure, just to make sure that there's not any issues with the column name being the same as this value right here, let's go ahead and replace this to say popularity value. So I'm going to go to code and then rename in scope and change all of those at once. Let's try rerunning that function, and let's see if we can apply that function to a value like, for example, 98. I'm still getting an error, so it's telling us this is an invalid format. Now I know from the code that I had generated earlier that this was originally S's, so I'm going to replace these with S and try that again. That time it seems to have worked, so let's take a look at the first value, and there we go. So now let's see what the entire table looks like. I also need to change this to say top hits df again, and again, because of the nano plot, it does take a little bit longer to render. Oh, and then because I had changed that to popularity value, I'm also going to change this to popularity value and this to popularity value. Let's try one more time. Oops, I had called that popularity SVG, not popularity value. Fix that and regenerate. So now it's showing up, but it's just showing up as text rather than being evaluated as HTML. So what we'll need to do is use the text transform function again. So let's try using a function that just evaluates the column as HTML, and let's apply that to the popularity column, right? Popularity SVG column, and see if that works. That's not working either, so what I'm going to do instead is just use the generate SVG circle function itself, and then apply that to just the regular popularity column. So it did partially work. You can see that there are different colors and different sizes, but the text isn't visible and the circles are way too big. So we're going to modify the generate SVG circle function to address that. After playing around with this for a while, this is a radius that worked well for me. And then after some back and forth with ChatGPT, this is what it came up with. So it added in a little bit of styling here, having the font size be dependent on the radius, centering the text, and so on. So we'll rerun that and see if that's any better. And now we have a much better solution. We can actually read the text and the sizes are much more appropriate. For the smaller circles though, it's really noticeable that the circle isn't centered. So I'm going to use the calls align function to center the popularity column. And I also realized that there's been some switching back and forth between pipes. So I'm just going to replace all of those with this. So here I'm using the calls align function and we want the alignment to be center, and we're going to apply that to the popularity column. Regenerate it, and now this looks a lot better. It's kind of hard to see with the high values of popularity, but as the values get smaller, the centering really does make a big difference. There's just one last thing I want to change about this column. These colors are okay, but they don't really match with the color scheme going on with the rest of the table. So I'm going to modify the generate SVG circle function, and I'm going to use this really cool function called color amp palette. And what this function does is it can create a gradient for you if you give it the starting color and the ending color. And in fact, you can even have more than 2 colors if you want. I know that I want this gradient to go from green to yellow to orange to red, so I'm going to give this 4 colors. And I've already picked out what I want those colors to be, so I'm going to copy paste in those colors. So I'm going to ask it to create a gradient for me using these 4 colors. Now, in order to actually use this circle color picker object that was just created, we need to create a gradient that is the same length as the number of possible colors that we might want to use. Because the popularity score can range from 0 to 100, that means there are 101 possible values that that variable can take on. So we're going to assign the color to be the circle color picker, which is a function, and the argument that it takes is n for the number of colors that you'd like to have in the gradient. So we'll set this to 101, and then within this generate SVG circle function, well, it's a function of a popularity value. So let's say that the value is 98 as an example. Then in order to determine what the color should be when popularity value is equal to 98, what we need to do is we need to take the 98th position in that vector. But because the value can range from 0 to 100, we can't index directly on the popularity value because we can't index on the value 0. So we need to shift all of the colors up by 1, and the index that we want is going to be the popularity value plus 1. So in other words, if the popularity value is equal to 0, we would instead be indexing on 0 plus 1, which is equal to 1, which is a valid index for this vector. And then it would go all the way up to a popularity value of 100, which would index on the value 101, and would again be a valid index for that vector. And now we can see that the color gradient has been applied, and these colors match the theme of the dashboard a lot better. The lowest number was 19, which is red, and we can see there's lots of variation in the color, including different shades of green as well as yellow. And really that's everything for the content of this table. So now it's time to add some styling to this table and to the rest of the dashboard. I want to add in some footnotes, specifically explaining what these popularity values are, as well as these tempo values. To do that, I'm going to use the tab footnote function, and we'll use the footnote argument to put the content of the footnote. This footnote is going to be for the popularity column, and I got the text directly just from the Spotify Web API documentation, and it just explains what the popularity of a track is and how it ranges. And then the location where I want this footnote to go, it's going to be on the column label for the popularity column. And then I also want to add a footnote to explain tempo. And for this footnote, I'm going to say that the tempo is measured in beats per minute and represents the speed at which the music is played. And then I'm going to explain what the nanoplot is showing. This visualization shows how the tempo varies across the different sections of the song. Sections with a higher tempo are generally more energetic and upbeat, while sections with a lower tempo may be more emotional or contemplative. And then I want this footnote to be attached to the column label for the tempo column. So I can set columns equal to tempo. And I also want to add a note that shows where these data are coming from. So I'm going to use the tab source note function, and I want it to say source in bold, and then I want it to have a link to the today's top hits playlist from Spotify. So the part in the square brackets is going to be what shows up as the text that's clickable, and then inside the round brackets is where we'll put the link that the user will be redirected to if they click on the today's top hits playlist text. And then it's from the Spotify web API. Let's re-render. So now I've got the one footnote and I've got the source, but the second footnote didn't work, so let's see why. And that's just because this should say tempos instead of tempo. And now they're both working. I don't really like how this is italic though, and I want to change it so that it's not italic. So I'm going to go into my custom.scss file, and I'm actually going to just erase everything that's in here for right now. And we're going to slowly build up this file to style the whole dashboard. In an SCSS file, there are two main sort of sections that you'll be working with. And the first one is this SCSS defaults. And that's the place where you would define the main colors and the main fonts for the entire project. And there's a second section where it says SCSS rules. And that's where we're going to put most of the custom CSS. And in order to get rid of the italics on the footnotes from the GT table specifically, the way that we can figure out how to do that is by first rendering the dashboard. And once it's rendered, we'll open it up in a web browser. I'm using Chrome. And then we're going to right-click on the thing that we want to change the style for. So I'm going to right-click on the footnote and then go to Inspect. And it's going to tell me what the class is for that thing that I'm trying to change the styling of. We can see here that the class is called GT footnote marks. And we can also see here that it's got this italic font style. You can also play around with the styling directly from within the browser. This isn't going to change the file itself, and if you close the web browser, it's going to go back to looking however it normally looks, which would be italic in this case. But if I remove the font style italic here, for example, and I instead change it to say font style normal, and I hit enter, then it's actually going to update that, and we can see that that is now no longer italic. This tells us that in our custom.scss file, what we want to do is modify the CSS for the GT footnote marks class, and we want to set a style that says font style normal. Let's go back to RStudio, and then we can add comments by using slashes and asterisks. And I'm going to say make superscripts not italic. And we're going to put the name of the class. So it's GT footnote marks, and then we use curly braces. And then inside of the curly braces is where we can put the style. So we wanted font style to be normal. But then notice here that within the GT footnote marks, that value of 1 is wrapped inside a superscript tag, which means that in our CSS, we also need to add that we want this to be applied to the superscripts specifically. Now, if we save and re-render, we can see that the footnotes are no longer italic, either in the column label or in the actual footnotes themselves. And the process that we use to figure out how to do that is the same process that we're going to use for the rest of the styling for the whole dashboard. Whenever there's something that we want to change the style of and we're not sure how to do it, what we do is we right-click the element and then we click Inspect. And we try to identify what the class is of that thing that we're trying to modify the style for. To keep this video somewhat short, I'm going to do somewhat of a speed run through the rest of the styling. and I'll just explain what each part of the CSS that I'm going to add does. So next I'm going to add in some default colors and fonts. I've picked a color scheme that matches fairly well with the Spotify colors, and I've also used a Google font. And then I've set the default colors for things like the footer background color, the color of links and sidebars, and so on. Next, I've added in some options that will make displaying tables look a little bit nicer. And here I'm changing the background colors of the dashboard itself, as well as the components within the dashboard, so that they better match an overall Spotify color theme. For the next part here, I've added in some theming for the scroll bar. So you can see over here that the scroll bar is now green. It has a sort of gray background. There's a different color when I hover over the scroll bar, and the scroll bar is a bit rounded. And then here we've added some styling to the drop-down menu, which is for this part right here. So we've set the background color of the drop-down menu itself, as well as the background color of the items that are in the drop-down list. Next, I'm going to replace the remaining placeholder content in the dashboard. I'm going to remove this placeholder text up here entirely, and then down here I'm going to put a card that puts some information about what this dashboard is for. And here I've added in a card. I've made the card so that it's not expandable, and what that means is on the dashboard there are these little buttons at the bottom that can let you open the element in full screen mode, but I don't want any of the elements in this dashboard to be full screen mode, so I'm going to add the chunk option expandable equals false to every single aspect of this dashboard. And then in this card I've added in some styling, and after re-rendering, this is what it looks like. I don't love the look of the underline on the links, so I'm changing that here. And then I'm going to make this title bold with this part right here. Here I'm changing the height of the embedded Spotify web player so that it takes up 100% of the container that it's in. This way it takes up a little bit more of the overall space and looks a bit better. Here I'm ensuring that if the user changes the size of the window, then the album art is always going to stay as a square image and maintain that square aspect ratio. And then on the dashboard, I find these numbers on hover a little bit difficult to read. They're pretty tiny. So what I did was I created a custom class called circle text, and I set it so that the SVG code that gets generated for those circles right here is of class circle text. And the reason why is because this highlighted text right here is the same class as the text that shows up when I hover on the nanoplot. And I want to be able to modify the size of the text in the nanoplot without modifying the size of the text in these circles. So by creating a custom class for the circle text, I can control the CSS for both of these things independently. And then in the CSS, here I'm saying that I want all of the SVG text in that table that's not part of the circle text class that I created. I want that to have a larger font size. And then that's going to exclude any of the text elements that are in that circle text class. So it'll affect the text that's here, but not affect the text that's here, which is part of that circle text class. And now when you hover over the numbers, you can actually see what each one of them says. Now, most of these numbers are fairly close together. For example, on this one, the tempo only ranges from 110 to 111, and these numbers are being rounded, so most of the variation that we're seeing here is less than 1 beat per minute in variation, but some of the songs do have more variety. This one switches between 184, 180, and 175. And finally, I'm going to add a bit more styling to the table itself in the tab options function. I can set the font size to be 12 pixels, and I want the borders to be not visible at all. So we'll get rid of these white lines. And now those lines are gone. There are still some lines at the top though, around the column labels. And we can get rid of those by using column labels dot border bottom color, and then repeat again for the top color. Now those lines on the top are gone, but it's pretty hard to tell the difference between each row. So we're going to add in some row striping so that each alternating row is a different color. And to do that, I'm going to use the opt CSS function, which allows us to apply CSS that's specific to this table rather than to the entire Quarto project. So this CSS that we want to apply is going to look like this. I just generated this using ChatGPT. I just asked ChatGPT to come up with some CSS to add row striping and also change the color when the rows are hovered on. And now the rows have alternating colors, and when I hover on one of the rows, it has this color that I specified right here. But there are still some cell borders that are happening. It's kind of hard to see, but it's more noticeable on the darker colored rows. When I hover, you can see that there's a little bit of a black line in between the rows, and I want to remove that, which I can do by using the tab style body function, and then the style that we're going to apply is going to be applied to the cell borders of the table, but specifically we want to apply it to the top and bottom borders of the rows in this table. And we're going to set the weight of the borders to be 0 pixels so that it just doesn't show up at all. But then for the tab style body function, we need to specify where we want to apply this to. And to do that, there's an argument where you can pass a function that you can use to selectively choose which cells in the table you want that style to be applied to. That's really useful, for example, if you wanted to have all the cells in the table where the value is greater than 10, you want to apply some sort of style to it. But for this example, we actually want to apply this style to every single cell in the whole table. So the function that we're going to use is going to be a function where it's always going to return true. So it's either going to be a cell that contains a number or a cell that contains a character. And for this table, this happens to be true all the time. So that's going to have the effect of applying this style to the whole entire table. And now when I hover over the rows, there's no more cell borders in between the rows. And now that I do have that row striping, I want to make it so that these last 3 rows, which are for the footnotes and the source, I want them to be this gray background color. To do that, we can use the tab options function again, and I'll set footnotes background.color and source notes background.color both to the same color. I've also added in just a few finishing touches. At the bottom of the SCSS file here, I've made some changes that won't show up on the dashboard, but will show up on the rest of the Quarto website that's associated with this project, including things like changing the colors of text in the sidebar. I also added more detail to the quarto.yml file. I added in an icon that shows up in the web browser right here. I also added in some links in the footer that link to the repo. So that's these 3 links right here. I added in a logo. I changed the syntax highlighting for the code cells to be using a dark theme. I made the sidebar a little bit smaller. And I also added in styling for the bottom corner on the scroll bar. By default, it shows up as white, but white doesn't look very good here, so now it's gray and you can't really see a corner on the scroll bar at all. When someone has the dashboard in full screen, they won't even see this scroll bar, but if someone resizes their window, then they're going to see both a horizontal and vertical scroll bar. And this is what the finished product looks like. You can scroll on the table itself, you can hover over songs, and hover over these values here, and they show up as visible, and you can change the songs, and they will update what's being shown. And the songs also play directly from within the browser.